This time we're supposed to find the area of the region enclosed by y equals the square root of x minus 1 and y equals 1/3 x minus 1/3. Notice the 1 to half scale going on right here. Just knowing about square root functions, we have to take the square root of a positive number or 0. I can see that x must be greater than or equal to 1 in this scenario. So if I'm going to go ahead and put 1 comma 0, so that'd be right here. And then if I pick numbers for x that create perfect square roots, that'd be helpful. So if x is 2, 2 minus 1 is 1. So the square root of 1 is 1, would go there. And notice again the half scale, 0.51. If I would pick x equals 5, 5 minus 1 is 4. 1, 2, 3, 4, 5. The square root of 4 is 2, that'd be right here. And if I pick 10, square root of 9 then would be 3. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1, 2, 3. That's all the graph paper I have supplied, so chances are that's right where we're supposed to be. If I want to graph y equals 1/3 x plus minus 1/3, I would probably assume, maybe wrongly, but I'm going to go ahead and assume that some points of intersection be these friendly points that I've got here. So if I just go ahead and try to pick 1 just to see what happens, if x equals 1, I'm going to get 1/3 minus 1/3 is 0, so that point matches. And if I tried each of these, then x equals 1, x equals 2, x equals 5, and x equals 10, hoping that one of those points that I already have graphed will match. If I pick 2, 2/3 minus 1/3 is 1/3, which would be about here. Again, 0.5 scale, so 1/3 is 0.333. If I pick 5, 5/3 minus 1/3 is 4/3, that'd be 1, and 1/3 would be about here. If I pick 10, 10/3 minus 1/3 is 9/3, which is 3, which is this point right here. So they do intersect at those 2 points. Again, you can't make an assumption like that. If that didn't happen, setting this function equal to that function, solving for x would find your points of intersection. So we connect these here, and that's not very good. So there's my square root function, and then my linear function. Try to make it kind of straight looking. And it makes that little sliver of a piece there that we're trying to find the area of. So we're trying to find how much space is inside that, pretend I didn't go outside the lines. All right. So again, our concern is what's the top, what's the bottom, and where are our points of intersection, the intervals, if you will. So we can see that this starts at x equals 1 at this point of intersection, ends at x equals 10 at this point of intersection. So 1 to 10 is our interval here. The top function is the square root of x minus 1. And the bottom function, of course, is 1/3 x minus 1/3. So if I write an area formula for this one, the area should equal the integral from 1 to 10 of the square root of x minus 1 minus 1/3 x minus 1/3 dx. If I go ahead and distribute that minus sign through that parentheses there, I get minus 1/3 x plus 1/3. Now, everything in that is easy to do except for the square root of x minus 1, even though that's not super challenging. But if I wanted to split this apart, if we take a look at the square root of x minus 1 from 1 to 10, let's add that to the integral from 1 to 10 of negative 1/3 x plus 1/3 dx. The green one there, I would probably go with u substitution at this moment. So if I let u equal x minus 1, then du, of course, is equal to 1 dx. And all the pieces there, this is u and this is du. We can modify this green integral into the square root of u du. And since this is a du integral, now I want a u interval. So if x equals 1, 1 minus 1 is 0. If x equals 10, 10 minus 1 is 9. So we can make a whole new integral out of that piece in a friendlier structure. And even better than that, square root of u is the same as u to the half power. Since we're integrating a half power structure is better than a radical structure. While I'm doing all that, I can go ahead and start figuring out this integral. We're going to get negative x squared over 6 plus x over 3. Keep in mind, this is x to the first power, so we bump that power up to a 2. That's the x squared. We divide by 2, which doubles the bottom, makes 6. And here, this is 1/3 x to the 0, which makes x to the first over 3. Just basic constant over a constant value, so just stick an x on it. At this point, the integral of u to the half power is going to be u to the 3/2 power. If we divide by 3/2, that's the same as times 2/3. And again, I'm just going to say that I changed the interval from a u to an, or an x to a u, from the x values of 1 to 10 to the u values of 0 to 9. So the green one's being evaluated on a 0 to 9 interval, the red one's being evaluated on a 1 to 10 interval. Just be careful that you keep that straight while you're doing this. I can go ahead and stick 10 and 1 into this here, so if I put 10 in, I'm going to get 100, but it'll be negative 100 over 6. And this is going to be plus 10 over 3. If I put 1 in, I'm going to get negative 1 over 6, and I'm going to get plus 1/3. I can see this reduces, but this doesn't, so I'm going to have to keep the 6 around anyway, so I might as well just not reduce that. The whole time I'm doing that, I can stick 9 into this one. I'm going to get 2 times 9 to the 3/2 power over 3, minus 2 times 0 over 3, which is 0. I get a common denominator 6 over here. I get minus 100 plus 20, so I double both things there. Minus distributes through, becomes positive, and that's already 1 over 6, so it's 1 over 6 still. This becomes negative, and I have to double everything, so 2. The green part, so I can continue figuring this out. The 9 to the 3/2 power, that's going to be 3 cubed is 27, so I get 2 times 27 over 3. Which obviously reduces down to a 9 here. So that makes 18. All this red stuff comes out to negative 81 over 6. Okay, which reduces by 3 down to negative 27. Oops, minus is already there. 27 over 2. That's over 2, so I'm going to make this 36 over 2. And then 36 minus 27 makes 9 over 2. So 9/2, 4.5 is the end result of that area. Main idea on this one, probably a U substitution scenario going on the test itself, so be prepared for that type of stuff there. I kind of did one, then the other, and one, then the other. You can work all this out by itself, work all this out by itself, just combine those answers together. Just be careful with that idea as you go through.